Hey, welcome to the Imagine Dockerizing Your Apps in No Time session for Elevate 2020. Here's a little disclaimer about this session. Okay, following is the session agenda. We will see what Docker is. We will also answer the question to why use Docker. We'll also cover some scenarios in which using Docker is a great fit. We'll talk about the new Docker features available in the latest SnapDevelop release. And we'll also cover the overall deployment process of Docker containers and orchestration. Here you will find some information about myself. And some details about Appeon. Okay, so let's start with what is Docker. Well, the official website says Docker is an open platform for developing, shipping, and running applications. Docker enables you to separate your applications from your infrastructure so you can deliver software quickly. With Docker, you can manage your infrastructure in the same ways you manage your applications. By taking advantage of Docker's methodologies for shipping, testing, and deploying code quickly, you can significantly reduce the delay between writing code and running it in production. Which means that I can take my applications and have them run in a contained environment. And this is called containerizing my app, which makes the solution portable, flexible, lightweight, loosely coupled, scalable, and secure. That way I don't have to worry too much on the whole infrastructure of each individual application. I can just focus my efforts in developing my application source code. So we need to keep in mind that Docker is an open platform. It uses containers to build, run, and share applications. And it has become a very popular framework for many software as a service solutions out there. Now let's look at the differences between containers and virtual machines. Sometimes this can become confusing at the beginning what the real differences are. Well, a container runs natively on Linux or Windows and shares the kernel of the host machine with other containers. It runs a discrete process, taking no more memory than any other executable, making it lightweight. By contrast, a virtual machine runs a full-blown guest operating system with virtual access to host resources through a hypervisor. In general, VMs incur a lot of overhead beyond what is being consumed by your application's logic. Simply put, imagine that a VM is like a cinema. You can go to the movies one night, purchase a ticket, get some popcorn, and watch the movie along with many other people there. That would be your VM. But a container is like watching a movie in the comfort of your own couch. Using one of those streaming subscription services so popular nowadays, where at the same price of a ticket, you can watch many more movies a month. So in both cases, you get to watch the movie, but you didn't have to worry of where you parked your car or how big is the line just to purchase the ticket. All you needed to do is hit play on your screen or even on your portable device, and that's it. So based on this analogy, I can run application A while application B, and I can play a romantic movie on the screen while I can play an action movie on my cell phone. Now, based on this analogy, Docker will encapsulate my apps in order to keep them isolated from the host or any other containers. The main advantages of using Docker and what problems it helps to solve are, first of all, it is flexible. Even the most complex applications can be containerized. It is lightweight. Containers leverage and share the host kernel, making them much more efficient in terms of system resources than virtual machines. Since Docker runs in the host kernel, there is no overhead for hardware virtualization and running the entire operating system, so it uses fewer resources and reduces cost. It is portable. You can build it locally, deploy it to the cloud, and run it anywhere. Docker ensures the consistency of the environment, so it makes the migration of applications easier. In addition, Docker can be run on all mainstream platforms such as Linux, Windows, Mac OS, physical machines, virtual machines, cloud platforms, etc. And the results are all consistent. Therefore, there is no need to worry about the problems caused by the change of environment. It is also loosely coupled. Containers are highly self-sufficient and encapsulated, allowing you to replace or upgrade one without disrupting others. Images of my applications are run inside containers, and the images are maintained in layers. Here's an official explanation of an image layer. If an image, a layer is a modification to the image, represented by an instruction in the Docker file. We'll talk about those here later on. Layers are applied in a sequence to the base image to create the final image. When an image is updated or rebuilt, only layers that change need to be updated, and unchanged layers are cached locally. This is part of why Docker images are so fast and lightweight. The sizes of each layer adds up to equal the size of the final image. Docker is also scalable. You can increase and automatically distribute container replicas across a data center. It is secure. Containers apply aggressive constraints and isolations to processes without any configuration required on the part of the user. Because Docker containers are completely isolated when running programs, they can be managed and controlled completely independently. Dividing large applications into different containers improves security, and if one container breaks, it has no effect on the others. It is easy to configure. One advantage of Docker is that it simplifies the environment configurations. There is no need to unify the operating system and environment configuration and install various component libraries anymore. Instead, you can simply package the development environment and copy the identical environment to migrate it to another platform. It is a fast deployment, and it has a fast efficiency too. Docker runs directly in the host kernel and does not need to start the entire operating system, so it can be started quickly, which decreases the time of development, testing, and deployment. In the traditional deployment mode, you could have, for example, installation of the package management tool or resource packaging, and then you would have to configure everything up and then run. But with the Docker deployment mode, all you need to do is copy and run. Let's now cover some basic Docker concepts. A Docker engine is a client-server application with these major components. A server, which is a type of a long-running program called a daemon process. A REST API, which specifies interfaces that programs can use to talk to the daemon and instruct it what to do. A command line interface, or CLI client. And simply put, it is a client-server application with a server, the Docker daemon, a REST API, and a CLI. The CLI causes REST API to interact with the daemon. Then there's the Docker client. The Docker client is the primary way that many Docker users interact with Docker. When you use commands such as docker run, the client sends these commands to dockerd, which is the Docker daemon, which carries them out. The Docker command uses the Docker API. The Docker client can communicate with more than one daemon. So it is basically used to interact with the Docker daemon, and with docker run and other commands are executed, the client sends the commands to dockerd for execution. Docker daemon. The Docker daemon listens for Docker API requests and manages Docker objects such as images, containers, networks, and volumes. A daemon can also communicate with other daemons to manage Docker services. So it is basically a background Docker process that handles requests for services such as file transfers and is dormant when not required. Docker registry. It stores Docker images. Docker Hub is a public registry that anyone can use. And Docker is configured to look for images on Docker Hub by default. You can even run your own private registry. So it is a service to store images as well as distribute and manage images. A Docker registry can contain multiple repositories. The large registry is the official Docker Hub, while others include a shared container registry, private registry, and so on. A Docker image is an image as a read-only template with instructions for creating a Docker container. It packages the application and its dependency in an image file, which is the only way to generate a Docker container. It can be understood as the class and object in C#. The class can generate the object, where the image is the class and the container is the object. Then we have Docker containers. A Docker container is a runnable instance of an image. The container instance generated by the image file is itself a file, called a container file. That is, once the container is generated, there are two files, the image file and the container file. And closing the container does not delete the container file, it just stops running. Finally, the Docker repository. A single Docker Hub repository can hold many Docker images. They are stored as tags, a place where Docker stores images files centrally, similar to repositories of code such as GitHub. A repository holds different tags for the same image. Okay, so let's take a look at when to use Docker. Whenever you need to develop, test, and deploy services in a consistent environment. When you need isolated operating environments. When you require a software as a service strategy. The focus of SaaS is to achieve multi-user data isolation under the same set of programs. And when you require high performance and an immense scale host deployment. Docker creates a container for a process without a need to start an operating system, and the time is reduced to seconds. Also, Docker can help you easily scale horizontally by creating another container. If you're experiencing huge spikes in traffic, just add more machines and increase the number of containers running behind the load balancer. SnapDevelop bases the process of development, deployment, and testing into one, thus making continuous integration, frequent deployment, and verification easier and faster. Deployment overall process. The publish basic process is we need to add a Docker support file, configure the Docker file, configure publish profile, and then publish. Configure and start the container, and then finally access the application and test. Okay, so it's now time to take a look into the new features of Dockers in SnapDevelop. So first of all, what I would like to show you is a project I have here. This project is a customer's project. It's a very simple traditional web API, and we have another one right here as well, products project. So both of them are actually running on .NET Core 3.1, as you can see, which is now supported, by the way. And let's go ahead and take a look what they are made of. So first of all, I have a model right here. This model, if you take a look into it, it's basically a data window that I converted over into .NET Core. So as you can see, this is the data window. It's based on this data object, the customer. And the next thing is I scaffolded the services and controllers. So this actually provided me with the following services right here. So I have a basic customer service and the basic controller that I need. And this is just a very basic CRUD controller. only for the purposes of showing you this application. So let's go ahead and test this method right here with this controller, which is the retrieval method of this customer controller. I would only need to right click on the method of the controller and run the test. By the way, I can also debug my test right here, but for this demo I'll just run it. Now this would actually start the Web API tester tool. Very nice handy tool which allows me to go ahead and test my Web APIs without me needing to create a new UI for me to test them. It also handles complex JSON for me. I don't have to be mingling around it. So let's go ahead and get this done. So what I need to do is test this retrieval method. I would only click on the send right here, the send button, and this has actually sent a GET request to this Web API, and it returned the JSON for me. This is very standard JSON, and this is the data window customer values that it's returning for me, and I can consume this with Power Builder or any other UI technology. So it has returned the status 200 OK, which means that my Web API is running and I can actually go ahead and use it. So now that we have seen that this Web API is working properly and that it's capable of returning values for me, what I want to do is containerize my Web API, and I want to put this in a Docker image. So let's go ahead and do that. Now, first thing to notice is that we have now added a new feature for this, and this is a new enhancement. This is the support of Docker. It has been enhanced in this version. So what I need to do is go into the project, right click on it, and then I can add Docker support right here. So by clicking right here, what this is going to be asking me is that it would be creating a Docker file for me. And this is the configuration file that I need to have so that I can actually create an image of my Web API. Then that image I can convert it into a container, and that's how I would actually run my application. So let's go ahead and do that. Now this is asking me to target a specific OS, and I can go ahead and use Windows or Linux, but I'm just going to be using Linux for this one right now. So I'll click OK. Okay, so this actually created a new Docker file for me. So if we look into this other project, you'll notice that it's not there. So this Docker file, if I double click on it, you'll see that I have everything necessary for my Docker to be supported, to be actually capable of running this as an image or creating the image for me. You'll notice that it's actually targeting the correct .NET Core version. It's exposing my Web API on ports 80 and 443. So those are the ports that I need to use to actually run my container. So now let's go ahead and take a look at some other details. So you'll notice that it's actually creating or getting the SDK for me ready to run and marking it as a release. And then it's building everything so that I can actually publish this. And some more configurations that we can use on it. Now, if I wanted to actually go ahead and add some more configurations on it, like for example, I would like to, I don't know, let's take a look at this. Let's say that I want to copy this or add an entry point or whatever I need to do. Well, this new window has a very nice feature, which is the code completion tool right here, which actually helps me to configure this file better, easily, and more rapidly. But right now I'm all set up so that I don't need to actually modify this file. It's already set up for me to actually go ahead and create an image out of it. So I can just close this. I won't save the changes to this file, so let's just click OK. And here we go. Now I have my Docker file again. Now let's go ahead and publish this as an image. Now what I need to do is right click on this, go to publish, and this is going to be taking me to this publish. So basically I would start here, but this is something that I want to do. I want to make a Docker image out of it. So I can go ahead and click here. Now since I have already done several Docker images, I can just use the one that I had before, or I can just go ahead and create a new one. Now this one right here is going to be helping me set the configurations for my publishing to a Docker image. It's also telling me if I want to target my personal repository, which I have set up before. and it's going to tell me what engine I want to do this to, or publish this to. So I will be selecting right here my local host, which is the one that I already have. But if I wanted to connect to a different engine, I can just click on new connection, and I can select if I want to connect to it using HTTPA or HTTPS. This is the engine URL and the port number, but I'm okay with the one that I already have. So I can also select a different registry. Again, I can do a new connection to it, or just connect to the ones that I already have. And then I can name my image, which in this specific case, I'm going to name it customers. And I can also tag it. So let's go ahead and do this. It's actually running, and it's actually going to be creating the image for me. Let's give it a second for it to continue. Okay, so this is continuing and it's almost done. Let's give it another second. Okay, so this is actually creating the image for me. It's actually compiling everything up, and it's publishing it to my engine, which I already showed you. It's already tagging the new image, and it has finished deploying or actually publishing my image. So let's go ahead and take a look where this got published to. Now there's another new feature that has come included in SnapDevelop, and this one right here is a tool. It is called the Docker Explorer. Now this Docker Explorer is very nice because we can actually go ahead and take a look at some very nice details about it. So let me just close this up, and I'll close this one right here. Now here I have my Docker engines. This is the local host I have, and I can also add some more, remember, right here. But let's go ahead and look into this one right here. So I have images. Here is where I would look into my images. As you can see, this is the image that I have created right here. And this is what I would be working on. So this is actually ready for me to start it as a container. So it's just the image. I still need to create the container out of it, but we'll look into that in just a moment. So right here we have a registry section, which we can find some more details about my images as well. And here we have the caches, where this is a place where I would actually be catching the information or a basic pre-image or pre-container that I get out of this image right here. So let's just minimize this for now. And finally, here we have the containers. So once I create a container from this image, this is where it would be placed at. So let's go ahead and take a look at some more details from this specific container. Now I can also get some more images if I needed to by right-clicking right here on the engine. I can pull some from the registry. So for example, if I need a specific image for, let's say, MySQL server, I want to run MySQL server right here, I can do it right here. And well, I can get any other images I might need from it. So this is my specific registry, which is the GitHub registry, and I can get any one of that I might need, but I'll just continue with the one that I have right here. Now let's see what else we need to do to get this running. So first of all, I would click right here on the image, and then I would right click on it, and then I would get some more details from this Docker Explorer window. Now I can run this a container directly, I can tag it, I can push it to the registry, or just delete it. But in this case, I'm going to run it as a container. If I click run, it's going to be giving me this window right here. Now this is a very nice window because it's actually going to be helping me set up the container details. So first of all, I'm going to give it a name. It's going to be named customer. I can auto remove it once I stop it. I don't need to do that, so I'll just leave it as is. I can publish all exposed ports, in this case like this, but I'm just going to be setting them up by myself. So here we can go ahead and see on the port binding details if I have a specific IP address I want to publish this to. And here is the host port, which is basically the way I would connect to it. And here is the internal container port. This is where I would be communicating to my internal port from the web API. Now I can also set up HTTPS if I wanted to right here, but I'll just leave it as is right here. Now there are more specific settings that I can set up right here. For example, volume bindings. If I need to allow some more access to different container files or specific folders, for example, this is where I would set them up right here. I can also set up environment variables, as you can see right here. For example, the path variable, I can set it up in here. ASP.NET Core URLs and some more nice settings. I can also create my own if I needed to. I can place the key and the value for them. I also can define a restart policy. For example, if my container has a failure, then it would restart automatically for me. It would always restart or unless stopped. So we can set that up in here. I'll just leave it as is right now. Then I can set up some more executable details for it. For example, this one here is to actually provide default for executing the container. Now I can also put on the entry point that you see right here. I can add some more values to this, but I'll just go with the ones that I have. So this is all set up. I can just click OK. And what this is doing is it's actually creating a container based on my image. The container has been created, and as you can see, this play button right here, that means that it's already started. And if I look over here to the right, I will see some very nice details about this container right here. So I get the ID of the container, I get the image where I created this container from. Here's my network default mode. The IP address this has been published to in the gateway, the date it was created. I can also set up the auto remove on stop and all this other settings that we looked into before. Now here I have the details for my port bindings, my environment variables and all that. I have my path variable and such, and the entry point. So if I want to actually go ahead and test this web API, I want to test this container, see if my application was actually or has been actually containerized. Let's go ahead and do that. I would now click right here on this port, and what this would do is open up the local browser for me. So I have already got this open, but let's go ahead and put the API URL, which is the correct one. And this one, in this case, for this specific web API, I want to use this one, and then click enter. So this is actually telling me that my web API has returned the JSON for me. This is what I was expecting, and this is very good news because that means that my web API is already running. So this is how fast and easy I was actually capable of containerizing my web API. Now, of course, I can also containerize any other project that is not a web API, but for this demo, I'm just showing you this example right here. So I'll close this up, and now that we have seen how to do that, I can also look into the logs. So if there were any specific log details right here for this specific container, then I would see them right here. In my case, I don't have anything for this specific. There were no error messages or such, so I can just leave it as is. Now let's look into more details for the container. There are some more specific functions that I can take a look into. For example, this container, if I right click on it, I can stop the container. I can execute a command for this container. I can restart it or just delete it. So let's go ahead and stop it. And as you can see, it's already stopped, and you can see that I don't have a port right here anymore because it's not actually running. So I can also go ahead and delete it. So let's go ahead and do that. That's already deleting it for me. And if I click right here, remember that I got this menus again. I can go ahead and delete this specific image as well. So there we go. We have already published my web API as a Docker image and container, and I have also run it. Let's continue on to the next part. Container orchestrator basic process. So first of all, we need to add Docker orchestrator support. Then we need to configure and start the service, and then we can finally access the application and test. Okay, so now let's continue on to the container orchestrator. Applications typically consist of individual containerized components, often called microservices, that must be managed sequentially if they are to function properly together. So we need container orchestrator. A process that organizes multiple containers is called the orchestrator or the container orchestrator. So if you want to conduct a container orchestrator, you can right-click on the project of each web API to add container orchestrator support. And this would actually add the Docker Compose project in solution and the Docker file in the project. So let's take a look at that. I would right-click right here. I would click on Add and then click on Container Orchestrator Support. Now what this would be telling me is what container orchestrator I want to use and what target OS I want to. So this would be Linux in my case. I would click OK. Now what this is doing for me is actually first of all creating a Docker file for this to be supported. And in this project, because this is the one I added the support for. So then I have my Docker Compose project right here. Now let's look into the files that this created for me. Now let's first of all start with the Docker ignore file. If I double click on it, you'll notice that I have a list of files right here or extensions. And this list right here is actually going to be telling my project that it can ignore the file types included in this build, such as the bin and the object files generated by the project, for example, here and here. So I can add a bigger list to this if I wanted to. And then I get the Docker Compose file. And this Docker Compose manages the projects such as the parameters, container name, expose port, etc. If it is specified when the project generates the image and launched as the container. So let's go ahead and take a look at it. And you'll see right here that I get the version number, the services that I want to actually publish. So in this case, I already have the customers. This is the image that I would create for me. And this is the build data about it. So basically, this is going to be telling all the configurations that I need for this to actually be published accordingly. So now that I have this already set up, I need to look into the second project that I want to include so that I can actually get this published as well. So what I need to do is click right here to expand it. You'll notice that I don't have a Docker file in it. I can either go ahead and click on Add right here and then select the Docker support file right here. Or even better, I can just click right here and add but the Docker Container Orchestrator support. If I do that, it's asking me again for the target OS, which is the one that I want to select. And after that, I can just click OK. And what this did for me, it actually created the Docker file for me inside of this project. And in the Docker Compose file of the Docker Compose project, it actually created a reference to that project as well. Now what I need to do to get this published correctly and get it configured to start the container and get this working as an orchestrator as well, I need to configure this. So let's go ahead and configure this. So I would just need to add the ports. Another nice thing about this, it's going to be including very nice code completion features. So for this example, there we go. I'm going to be adding the port number that this is going to be binding to. So this is the external port number, and that's the internal container port. And then I would place a container name, which in my example, I would like to call this the customer container right here. And then I'll do basically the same thing for this one right here. So it's again setting up the ports that I want this to communicate on. So in this case, this is going to be port 8082 and the internal port would be 80. Then again, I need to add a container name right here, and this would be the products container. As you can see right here, I can now save the changes. Now to actually get this running, I can go ahead and publish this, or even better, I can directly go ahead and debug my web APIs directly from here. In this case, I can just run it as a Docker Compose and or run the test on it, or I can go ahead and run it directly from here. So if I click here, what it's actually going to be doing, it's generating the images for me. Remember the customers and the product images right here. Then it created the orchestrator, and inside of it, it actually created the containers. Here's number 1 and here's number 2. And as you can see, all the data for the containers are in there as well. So this is actually making it possible for me to go ahead and test it. Okay, so now that I have this published, I can actually go ahead and test this out. So let's go back to the browser, and right here on the browser, you will notice that I have this already loaded right here, but I need to test the web APIs, which are the ones that I'm interested in. So let's go ahead and look for localhost port 8081, as you can see right here, and then we have the API d_customer retrieve. So that's the one I'm looking for. Let's click right here on enter, hit enter, and there you go. You can see that the customer is running. It's already returned the JSON for me, and the one that I'm testing is this one right here, as you saw right here. Now let's go ahead and take a look at the second one. That's the products controller right here. So let's go ahead and go for it's not going to be port 8081, so let's go look into localhost 8082 instead. So this is API d_products retrieve. Let's hit enter. There we go. It has returned the JSON for me. Now I can also perform some more specific processes for this and do some more maintenance onto this container. So for example, if I want to stop this container, I can just right click on it. I can stop it, I can execute a command to it, I can restart it or delete it. And I can also do the same for the orchestrator itself. So as you can see, I can either start it, stop it, or put it down. That would be basically deleting it. So let's go ahead and do that. Let's first of all stop I can individually stop each one, as you can see right here, or I can do both at the same time. So I'm going to stop them both. And then I can just go ahead and tell it to take them down. So here we go. There we go. That has completed me the process that I asked it for, and I can now go ahead and continue developing, or I can create another container, or I can create another orchestrator, or whatever process I have. Okay, so we have now talked about publishing my application as a Docker image and then running it as a container. And we have also seen so far how we can also manage orchestration of my Docker containers inside of SnapDevelop ID. We have also taken a look at what Docker Explorer is, how we can easily manage it and handle it and use it, and how I don't actually need to open any other tool to actually get this up and running. And we've also taken a look at how we can actually go ahead and test my web APIs and see that they're running and working properly. But now let's see how this looks inside the Docker desktop. Now remember, Docker desktop is a third-party component, and I'm just going to be displaying this right here so that you can better understand what this actually did in the Docker environment for me. So let's go ahead and open the Docker desktop right here. Okay, let's give it a couple seconds for it to load, and here we go. Okay, so the first thing we need to see is that Docker is running, as you can notice right here. Let's take a look into the images. So remember that I had created images. So here I can see the images I have done and which ones I have already worked on and my testing and so forth. But this one's right here. This is the customer's dev. Remember, I placed a tag to each one of them. These are actually the ones that are in use and I got them already running. But let's say that I wanted to see more details about this image. So I can directly, well, first of all, I can see the image ID when it was created, the size, the tag. But let's go into more details. Let's select this one, and I can click right here and I can do an inspect. So by inspecting this, remember I told you that layers are part of an image, how we can actually layer my image and actually update it and so forth. So these are the layers right here, as you can see, and I can see that I have actually made some changes to them, which are right here, and it tells me the size of them and so forth, and I can see the command right here as well. Now if I go back, I can do the same thing for the next image. I can also look into remote repositories, as you can see right here. But then again, let's continue on to the containers. Now remember, I have my orchestrator. This is the one that's running, as you can see. And here's some more details about my CLI right here, and some more details about my containers. In this case, the customer container. Here are my logs, and I can also inspect it and take a look at some statistics. But again, this is more elaborate stuff that you might want to do if you're actually maintaining a whole ecosystem of Docker files and so forth. If you just want to deploy them, get them running and testing them and so forth, even publish them to your registry or repositories, you can do everything right in SnapDevelop directly. You don't need to be getting on to different compiles and complications and so forth. So everything was done here directly on SnapDevelop. Don't forget that you can connect with the Appeon community at community.appeon.com, and here we have some more links to Appeon. Thank you.